Hi everyone, my name is Raj and I work for Compare the Market as a data engineer. So today we're going to cover how to deploy an API using a variety of AWS services. So what are we going to cover today? For anyone that doesn't know, AWS stands for Amazon Web Services. We'll be going over what is AWS API Gateway, how do we use it to create and manage our APIs, then what is AWS Lambda, how does it work, and how will we use it to deploy APIs. In this session, we'll also create and deploy our own API and then make requests to it using Postman. Just to note, we won't be creating a front end for this API today. Instead, we'll be using Postman to hit the API and get a response, just so we can see the outcome is as expected. After the demo, we'll go over a section on what else to consider when developing our API. So hopefully by the end of the session, you'll be able to create your own basic API just to get started and just an understanding of the infrastructure and how you would deploy your first API. Then at the end, I'm going to lead on with a few things you can do with the API to carry on your learning. So before we get started on what is AWS API Gateway, I just want to go over what is an API. API stands for Application Programming Interface. It effectively acts as a middleman between applications, enabling them to exchange data and functionality easily and securely. So when I think of an API, I think of a request handler. So we can see in this diagram, we have a web app and browser that sends a request to an API, which then processes that request. Usually the API request includes parameters, and then the API processes this request, possibly getting data from a database, and then returning it to the web app, which it then uses as an object. So a good example of this would be of two applications. We have a React application, which is a front-end login page. It has a form that says username and password, and then a login button. So as a user, I'd pop in my name, Rajal Hussain, as my password. I'll pop in password. I'll hit login, and that's going to send a request to the API. And the API is going to process if that's a valid login or not. If it's not, it's going to send a response back to the web app saying, sorry, not a valid username or password, which can then be displayed in the React application. Or it might say, oh, that's a valid username and password. Go into the database and it would gather the details it needs for the request. So in this case, it's going to send back all the information that the user clicked in. So if they wanted to view their profile in a social media app, they'd get all the details for that, and that would be displayed in the React application. So an API is the middleman between two applications, allowing them to communicate. And we see them all the time when we use Google APIs for maps. So the first service we're going to use is called AWS API Gateway. So before I get into that, what is Amazon Web Service? Amazon Web Service is a cloud computing platform that provides customers with a wide array of cloud services. So it can offer us infrastructure, compute power, or storage. There's a lot of different services that go into Amazon Web Services. So Redshift, for example, DynamoDB as a database usually can be set up within minutes, and it's kind of taking over the normal on-premises sort of database and infrastructure, so we don't have to manage that ourselves. And with services like API Gateway, it makes deploying APIs very easy. In fact, it's just a matter of a few clicks, whereas without sort of AWS, it'd be a lot more long-winded, and there's a lot more infrastructure thought that goes into it. So Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. What this means is AWS API Gateway is a way to decouple the client interface from your backend implementation. It allows us to easily create and manage APIs. It takes care of the infrastructure for the most part for us, and lets us just focus on managing the API in terms of adding new methods, resources, and security. It allows us to create and deploy an API within minutes and hook it up with other AWS services such as Lambda, EC2, or AWS Gateway in our case. So so this is the second service we're going to use today to deploy our API, and this is called AWS Lambda. It is a computer service that runs code in response to events and automatically manages the computing resources required by that code. So we don't have to worry about hosting the Lambda itself. Instead, we focus on what triggers the Lambda to execute the code. There's a variety of services that can trigger our Lambda, so it's always event driven. This includes S3, SNS, and in our case, an API request. Out of the box, Lambda supports multiple languages such as Python, Node.js, but in this case, we're going to be using Python to write our code. And Lambda also has access to all of our other resources within our AWS account and infrastructure. So our Lambda can access different services within our account. That's why API Gateway can trigger a Lambda, which can go to our databases within AWS. So all these services are interconnected within our account, so we can use them for each other. So it's okay if none of those services make sense yet. Once I open up the console, it'll start making a lot more sense on what these services are and how they work. So once we get into that, hopefully it'll just make a bit more sense if it doesn't right now. So how will our API work? So before we get into it, what we're going to build is mostly on the right-hand side. A request will be sent to our API, which will trigger the Lambda. And given the API gateway will also give in parameters to the Lambda to process. We won't be sending empty requests to Lambda. And so in response, we'll be sending, as we can see, a website on our left. Instead, we'll be using a Postman application, which is going to send a request through the internet to our endpoint for API. Our Lambda is going to take in that request, and with those parameters, it's going to process the request and send a response back, which is ultimately going to go back to our Postman application. Our API will be public, so by the end of it, our API can be accessed by anyone on the web using the mobile apps, websites, web services. In our case, we won't be using DynamoDB. On the right-hand side, we can see the final stage of our API is going to be the AWS Lambda. Usually, an AWS Lambda would connect to a DynamoDB or database of some sort, but in this case, we're just going to be mocking out the data ourselves, and then that's something we can talk about afterwards. So what are we building today? We're building a public API that allows us to manage stock in our store. It's going to be a simple API that allows us to view items in our stock, delete and add items in our stock. We'll be writing our Lambda in Python to process the request. We're also writing this, as I mentioned before, this API as a public API, so it'll be available to anyone who has access to the internet as opposed to just within our VPC in our AWS account. I'll go into public and private APIs later and the benefits of each one, but for this demo, we'll just be working on a public API. So let's just get started on the actual demo itself. So that's not what we want. So I'm just gonna load up our AWS environment. So this is an AWS environment account that I set up for this demo. This is a free tier account, so anyone can sign up to this, and I'd really recommend having a crack and signing yourself up for an AWS free tier account. You can play around with a lot of services. So the three services we're going to look at today are Lambda, CloudWatch, API Gateway. Most importantly, Lambda and API Gateway. So we're going to click into services. That's not services. And we'll see all the services AWS offers. So we have compute, container, storage, database, developer tools, and so on. Today we'll just be focused on compute power. So the first thing we want to set up is our actual methods itself that are going to be called by the API. So our most important piece is our Lambda. So once you open up the Lambda service, you can see we have a few options inside: a dashboard, application, and functions. Functions is what we're specifically focusing on now. We have 0 functions at the moment. So I'm just going to create a new function. And we can see there's different ways to create a Lambda function. We're going to create ours from scratch with a blueprint and container image that you can download, or browse serverless app repository. In our case, we're just going to create it from scratch. So first thing we need to do is give our function a name, and the first process of our API is to get an item of all the stock we have in store. So once we assign a function name, Lambda's really cool in a way where you have a lot of supported languages. So we're just going to focus on Python. I'll just click Python 3.6. architecture, we'll just leave that as it is. And every sort of Lambda needs its own sort of role and permissions and who can access the Lambda and who's able to create a Lambda. So we'll just leave the permissions as it is. And we're just going to create our function. Just take a second. So as we can see, successfully created the function getItem. You can now change its code and configuration. To invoke your function with a test event, choose test. Right, so here we can see our function overview. And as I said before, Lambdas are always event driven, so they always need a trigger, and they can also lead to other Lambdas being executed or different destinations. But in our case, all we want is a trigger. So we can see the different type of services that activate our Lambda and trigger the code. We have API Gateway, AWS IoT. There's quite a few different services, mostly S3, SNS, and SQS are the most common ones. So if we go back to Lambda, into functions, we'll see our functions being created called getItem. And this is the code that's hosted that will be executed if the Lambda is ever triggered. The entry point for a Lambda is always a Lambda handler. So all of our logic needs to go, this will be the entry point. So we need to make sure key logic is in here. So I've already written out the code that we're going to use for our getItem Lambda. I'm just going to copy across and then we can go over what the code does. So I'm just going to replace this here. So the first thing we're doing is importing JSON because that's going to be needed to send a response across. So like I mentioned before, we're not using DynamoDB to store any data. Instead, we're creating a dictionary with a nested dictionary that's going to act as our data. So every time we do trigger the Lambda, the dictionary will be reset and will always have the same set of products. And I'll talk more about that later around why I've done that. So in our case, we have our entry point, the Lambda handler. It takes an event and context. It's good to just take a note of this event parameter now because it's going to come up again later. So what the code does is creates a variable item and sets a query, it uses the event parameter to pull item from it. This value is going to be what's passed in through the API. So if the user sends an API request to get item and they choose cake, this event's going to come through and we're going to pull cake from that event value. So in this case, item will be whatever items passed into event when doing that, the API request. And so once you have an item here, let's say, for example, chocolate in our case from our store of stock, it's going to look for chocolate within our store. It's going to find it. And once it does, we're going to start putting together a response body, which is the response our API is going to give to our client. So response body is empty. Response body item to get, we're going to assign it, in this case, chocolate. And then the message is probably the most important part of the API response when sending back to the client, because this is what will be used. So response body, the message of the body is going to be a format method of chocolate. We have units, we have 10 in stock, and the cost is 3 per unit. So we're just using the format method to just sort of fill in what would go in between these brackets based on what's passed in through the item variable. If we can't find item in store, we're just going to respond with failed to find item in stock. We're not going to raise an exception here. Instead, we're just going to send back a message saying, sorry, there's no item in stock, which then the client could then use to present to the user. So very simple if statement. And then we have a response here. This is the response that we sent back to the client, sorry. So the response status code needs to be 200 to make sure it's all okay. And the header's content type needs to be application JSON because we're sending back a JSON format file. So response body equals JSON dumps response body. So we're sending across what we've put together here. And then we return the response. This is going to go back to the API and return to the client. The code in itself doesn't matter too much because when you write your own API, you use your own logic. So I just wanted to create a simple API that we can understand what's happening and just able to see if the messages are pointed to the postman. So it's really easy to deploy Lambda in the AWS environment. Once you've written your code, you just click deploy. And it's as simple as that. Our Lambda is being deployed and these changes are live in our AWS environment. So that's our actual logic ready up and running. Now we just need to create our API. So API Gateway, this is the next service we talked about. So we have, for this case, we're just going to create a REST API. We can see there's two types of APIs, two types of REST APIs. We have REST API and REST API private. For this tutorial, I'm just going to create a REST API, and then I'll talk about why later. So let's just build our API. Create your first API. Welcome to Amazon API. To create your first API, we have pre-populated the input form with a pet store defined API. So this is really good. If this is the first time you're going to use this service, I'd recommend definitely having a read and looking at how this API gateway works. The documentation and the hints in AWS are really, really good. So, but in our case, we just want to create a new API. And we'll just call the API store. Description, store, and we'll create the endpoint type as regional. So it's as simple as that. We've created our API and we can deploy this at any time to be available to anyone on the internet. It's just got nothing in it and it won't do anything. So what's important is the very first thing we need to do is, this is our store API, and store can have many sort of services. We might have a section that's for stock, for managing staff, or managing orders. For our section, we want to create a resource called stock. Let's create our resource within our API. And now once you create a resource, every resource you can create a method within that resource, but it's very important to know for each resource, you can only have one type of HTTP method. So in our case, we're going to use a get method because we're just going to retrieve information about a item. So we'll just get, create our method. And then once we get into it, we're just setting up our get method. So choose an integration point for your new method. We want a Lambda function to be triggered whenever there's APIs called upon. We also have HTTP, mock, AWS service, VPC link. And we'll just select Lambda function. And then we have use Lambda proxy integration. We want to take this. If we can see this message, request will be proxy to Lambda with request details available in the event of the handler function. So I went over how the event parameter was going to be used to kind of pick our request from the API, what the parameters were. So we need to click, select this so we're able to use the event parameter to get, the event parameter to pull the parameters from the API request. So once we take that, we can select a Lambda function. And it just creates a list of what Lambdas we've already created. So we're just going to select the get item Lambda. And we're just going to save. You're about to give API gateway permission to invoke Lambda. Yep, we want that. So here we can see the method execution. So we have the client here, which we're going to be using Postman, but you could of course have a front-end application, a React application that would hit the API endpoint. And then we have an authentication, which I'll come on to later. Our integration request is Lambda proxy, which we just selected. And then which is gonna hit our Lambda get item code here. So if I click that, we'll see our Lambda get item, which now has an API gateway trigger in it. So that's good to see. And once that triggers it, that'll execute our code, return the response to the API Gateway service, which will then in return return it to the client. So I'm just going to go back to API Gateway. Back to our store API. Back to our get method. And to release this to the internet so it's out there, what we're going to click is Actions, Deploy API. We have option to put in a development stage. So in a real world product, the development stage could possibly be the test environment, and then a production environment. So in our case, we're just going to create a new stage and we're just going to call it test. And then we're just going to deploy our API. So these are our stages. This is our test stage, and this is our URL to our stage, but that's not what we're looking for. We're going to expand our stage test, go to the stock resource, get method, and this is our invoke URL. So I'm just going to copy that, and we're just going to go to Postman. We're going to paste the link in, and item key, I believe it was item. Let's look for cake. I believe that was one of our, item to get cake, and our API responded. So our API gateway was hit, it accepted the request, and then triggered the Lambda, which passed cake as a parameter, and then it applied the logic cake. We have 10 units in stock, and the price is 1 per unit. So our API is technically live. What we could do is create a front end for this that will just be a simple management system. So we have cake. Let's try Coke, and let's send that across. Coke failed to find the item in stock, so that's good. Once you can find the item in stock, you just gave the message we wrote in the Lambda, failed to find the item in stock. Great. So our first API is live, and we've got a method working. So that was the first part. Now we're going to look at how we can have multiple Lambdas off the one API. So I'm going to go back to Lambda, and I'm going to set up another Lambda function. It is just that, a function. So let's create a new function, and we'll call this add item. Again, Python 3.6, create function. Yep, just take a second. And again, our Lambda is being created. It has no triggers, no destinations. So what we want to do this time is go back to our code, and now we're going to use the add items. Again, similar logic. Got our dictionary at the top. That's sort of marking our database. We have our entry point. Now we take in 3 parameters that we need. We need item, units, and cost. So we need each instance of a item name, how much we have in stock, and the cost. And then we're going to use a basic try and accept block. We're going to try adding the new item into the dictionary with the unit value and the cost value in a nested dictionary. And again, we're going to, similar to the previous file, we're going to create a response body item to add. We're going to use the item that's passed into events, and then the response body is going to be successfully added item. You now have store, so we'll be returning the whole store so we can see our value being added to the dictionary. So, and the rest is the same. If it doesn't work, an exception block, we don't want to raise an exception. We just want a fail to add value. So we want the code to execute. So I'm just going to copy this across, and that'll do. So we'll keep the import JSON. And we are going to deploy this. So our changes have been deployed. Brilliant. That means we can now add it to our API. So Amazon API Gateway. Back to our store API. This time, we're going to click back into our stock resource. We're going to add a new method, which is create method. And this time we're going to use the post HTTP method. As you can see, we can't use the get one anymore. So it's only one method per resource. That's why it's good to sort of separate your API into different resources, because if we had it under one resource and we wanted to add a staff member to our staff list, but we've already added an item to our stock, you can't really add a new HTTP method twice. So we have post there. Just gonna create it. Again, same thing. Integration type, Lambda function. Use Lambda proxy integration. Yes, we want that. US East 2. Just quickly go over this. This is where our data center is located. AWS has data centers all around the world, but I believe if you've created your Lambda function in US East 2, you won't be able to go to US East 1 and then use what Lambda you've created in US East 2. So sometimes you come across a problem, you can't find where your Lambda is, or you can't find where your service is. It's good to know just to make sure you're in the right region. So this time, we have our add item. It's added to the dropdown. So add item. And we'll just save that. I'm about to give API Gateway permission to invoke your Lambda function. That's good. Great, so now it's again the same thing. Method request, no authentication, integration type Lambda proxy. This time we can see it's pointing to our add item Lambda function now, as opposed to the get item, all within the same API. And then we're sending our response back to the client as JSON. So before we go to Postman, you need to make sure you redeploy your API. Development stage, we're in the test environment again, and we're just going to deploy. Cool. And what you'll notice is, so we're in the test stage again. In our stock resource, we have two separate API methods. But one thing you'll realize is they're both the same link, exactly the same. The only difference is what method's being used. So we don't need to update our link in Postman. We just have to change the method here. So now I believe it was post we kept, and this time we're going to go item, and I think it was units and cost. Okay, so we'll add some Haribos, and we'll have units, we'll have 1,000. And for cost, I think it was, we'll have 2. So item to add, our API successfully responded. Message successfully added Haribos. You now have, and now this returns our dictionary. We can see Haribos has been added to our list. So if we did have a stock management system, our front end would then display this message saying successfully added so-and-so. Here's your stock now. But instead, we just have it in a JSON format. So let's try, what happens if I get rid of one? I feel like this is going to throw an internal server error. Yep, internal server error. So we're going to go over what to do to validate your input later. But in this case, we're just going down the happy path. They've added in item, units, cost, and it's updated your dictionary. Cool. So we're able to get items and we're able to add items. The last part of our use case is to delete items from our stock. So let's go back into AWS services. We're going to go into Lambda. And we're going to create one more function. There's no limit on how many functions you can create here or how many sort of methods you can attach to API. I don't think there is. I'll have to confirm that, but let's create a new function here. Author from scratch. This time we're going to look at deleting items from our stock. So again, runtime, Python 3.6. Permissions, that's okay. Let's create our function here. So again, no trigger, no destination. It's just sort of a standalone Lambda that doesn't really do anything at the moment. So let's copy across our last piece of code, which is delete item. Very similar to the previous ones. We've mocked out a little data set of data here. And this time we're only taking the item parameter from the original API request. And what we're going to do is look to try to delete that with a basic try except block, and just delete the item and return with a message that says successful deleted item. You now have this in your store. If not, item to delete failed, and then respond with the same thing. Status code 200, headers content type application JSON, and body equals JSON.dumps response body. So let's copy this across. And let's deploy. Great. So back to our API. So back to our store. And we're going to look at creating another method. Oh, no, sorry, that was within the wrong area. We want to click on stock first, our resource, create a method, and we're going to get the delete method. And again, Lambda function, use proxy integration, US is2, and we're just going to point to delete items and save. Brilliant. So we just see the same thing again. This time we're pointing to the delete items Lambda, so we can see our three methods. They're all fundamentally the same. The only difference is what Lambda they call on the right. So the get calls a get item Lambda, the post calls the add item Lambda, and the delete calls the hopefully delete items Lambda. Cool. So let's redeploy our API to our test stage. And hopefully that is now live and can be accessed by anyone on the internet. So again, it's the same link. So this time we're going to go into delete. And let's delete. So for this one, we only need, I'm sure I'm just going to click. Let's delete what we have for cake. Items delete cake, successfully delete cake, you now have, and that's our response object that could again be used by the front-end application. So effectively what we've done is we've created our first API and launched it to the internet. So anyone can access this right now. I'm aware that it's a really simple API and the logic is a bit, doesn't really do much. We're not even connected to a database, but I just kind of wanted to get across how easy it is to kind of deploy an API to product live out there on the internet right away. Something like this for this product specifically, you wouldn't really make this a public API. Instead, it'd be more of a private API within your AWS environment, and then other applications or services within your environment would use that API. So I'm just going to go back to the presentation, and there's a few things I want to go over. So if we just go back, yeah. So there's a few things to consider. So we've created an API, but we need to make sure we have login. Luckily in AWS has a service called CloudWatch, which allows us to monitor logs and metrics, which includes every time a request is made to our API. Because it's out there in the wild, essentially anyone can access it, and we want to know what they're doing with our API and what happens every time our Lambda is invoked because of this API. This allows us to see how many requests are made to our API, the details of each request, such as parameters passed in. It's also a good way to see the demand of your API by internal or external services. Monitor if it's being used somewhere it shouldn't be, and see how long it's been used, how it's being used based on the parameters that are being passed in. It's also useful when developing the API and debugging any issues by seeing how the process is failing. For example, looking at the logs and seeing what errors you can help with the development of the code itself. So it's good to always have that to look back onto. So again, that was simple API, but there's a few things to consider when developing your API. We noticed when I tried to pass in 2 parameters instead of 3, we got an internal server error. Validating incoming data is crucial, which is the request. What may seem straightforward to the developer may not be as straightforward to the user because they didn't work on it. We need to ensure that the data coming in fits the criteria we're looking for, which could lead to a crack in the system or the API being misused. Secondly, we don't want to overshare data in our response. Did you notice how whenever we sent a response back, I just sent the whole store details back to the user? So we need to make sure whenever someone sends a request for the API, we only send back what's required and we're not oversharing what could be sensitive data. It may seem faster in the short term, just sort of develop it so it sends back the object. It may seem a bit long-winded to pick the object to only send back what it needs to, but in the long run, it's going to save you a lot more time and it sort of make sure no one else gets their hand on what they shouldn't have, which could cause you problems in the future. And the correct usage of HTTP methods is important too. So the HTTP methods we use were post, get, and delete, I believe. We want to make sure we're using these correctly. If we're using the delete HTTP method, but we're adding an item to our data, that can be really confusing for the users, and the documentation would just be really difficult to read. So we want to make sure we're using the correct usage of the HTTP methods. So what else to consider with our API keys? Because our API wasn't really doing much and it was just more about getting out there, there's a few things to consider. An API key is a unique code that is passed into an API to identify the calling application or user. API keys are used to track and control how the API is being used. For example, to prevent malicious use or abuse of the API, we don't want everyone just having access to it. API Gateway service on AWS allows us to create these API keys. They're usually alphanumeric values and they help us authenticate, and we send users, and we only send them out to people who we want to have access to our API. So certain applications on our estate or certain users, third-party developers, we'd send them a key saying this is your key to use our API. It also allows us to sort of see who's using the API. If we're looking at the logs, we can reference that key back to a user. And now to public and private APIs, we need to think about how we're creating our APIs. We need to decide if our API will be public or private. If it's public, it can be accessed by third-party developers, and a private API can only be accessed within our AWS estate. In the real world, the API we created, that wouldn't be public. That would be a private one within our estate, whereas a public one would be something like Google services. They offer a Google Maps API, which when you go into your favorite website, you'll see. So in the contact or about us, there's always a Google Map API there. And Google have released that API publicly so people can add it to their website as opposed to the developers sort of working on it themselves. So when developing your API, you need to consider will it be a public API or a private API. It's really crucial. You don't want anyone out there getting access to your API and then just having access to your data too. So always keep that in mind. There's always different use cases for APIs. So we covered the login API at the start. We covered our API that we've created to manage stock, which is more of a private one. And then we covered the Google Maps API. So there's a lot of different use cases for it, and it can almost be used in any sort of situation. Really easy to implement through AWS Gateway, and you can get them live really fast. So before we finish off here, if you want to learn a bit more about APIs, definitely recommend looking at the AWS free tier account, have a play. I say this because when I first started developing on AWS, I went straight to Terraform, and didn't really understand the AWS console itself. And managing AWS infrastructure, such as setting up Lambdas or API gateways in Terraform, can be very daunting because it's all managed by code. So what I would have done is I would have signed up for a free tier account first, have a play, see how easy it is to deploy stuff, have a better understanding of the services, and then worry about the Terraform. So I definitely recommend signing up to a free tier account and then just playing around the services. It's all free, setting up databases, Lambdas, even an API, possibly the same API. Look at the AWS documentation. It's really, really handy. They cover all bases. Whether what you want to do the API, AWS gateway, there's nothing they've left untouched. So it's a really good learning material. And then the Be a Better Dev YouTube channel is brilliant. It has so much about deploying APIs using AWS services, so Lambda or EC2. And there's just a bunch of good content on there. So I definitely recommend that. So if you want to carry on learning more about APIs, what I'd recommend is follow this tutorial again, set up your AWS, set up your own API, following it exactly along with your free tier account, and then start making a bit more improvements to it. Instead of having a hard-coded dictionary in every Lambda function, this is your chance to set up a DynamoDB sort of database and then hook that into your Lambda. So now you're looking at live data within your AWS account. And then you also want to make a private API and possibly build a front end using S3. There's a lot of good documentation on it, and then that would be deploying your Lambda to production. But I think that covers everything I wanted to go over during this presentation.
Hey, thank you so much for that. If anyone's got any questions, please do drop them into the chat. And we've got 10 minutes. One question has come in that says, can we say Lambda is an endpoint?
No, so Lambda wouldn't really be the endpoint. In this case, yes, but usually it'd be Dynamo. We'd go into DynamoDB services, and that would be our endpoint. Or API. Or
oh, someone said, can you please share your code?
Yeah, absolutely. I'll. Is there somewhere I can upload it or send it across?
Yeah, well, if you can send it over to me if you want, and then when I upload this to YouTube, I'll make sure that there's a link with some of the things that you've mentioned here, particularly this last screen, and a link to your code as well.
Yeah, I've also wrote a script for a slightly more complex API, but it covers the same ground of what could be the next steps. And I can also send that along as well, which separates the DynamoDB into its own service as opposed to being hard-coded.
Perfect. Yeah. That'd be wonderful. Thank you. Well, someone has said specifically, I would love to see the Python implementation for the controllers.
So I've not really touched that before.
Okay.
Within AWS. Let's definitely have a look at.
Yeah, that's fine. What are the limitations on the free account?
So I think it's free for 12 months, and then you have a limit on how many requests can be made to your API. I think it's a lot. I think there's something around 10,000 requests. You get a certain amount of storage, and within your services such as DynamoDB, and you get a certain amount of compute storage, but there's always a warning about how much you have left before you go over. So it's really monitored, and there's actually quite a bit of leeway on how much services you can use and how many times you can access them. So it's a really, really good learning material just to get a free tier account and just having to play with the infrastructure.
Perfect. And someone has said, where can I start as I've not done any of this before?
So I definitely say Be a Better Dev YouTube channel. It covers a lot of grounds, but if you're completely new to AWS, I think the best thing is just to sign up for the free account and just start with every documentation about what services you want to learn about. The documentation at AWS is great.
Cool. Okay. Well, there aren't any other questions coming in, so I guess we can wrap up. And a huge thank you, Raj, for coming along and giving us this talk. It was incredibly insightful, incredibly useful. And I know lots of other people have been commenting throughout as well and saying it's very useful. So huge thank you, and a huge thank you to everyone else from Compare the Market as well for putting this event on.
I hope you enjoyed it.